Alright, let's look at solving systems of equation. First by graphing. Solve the system by graphing. That means we have two linear equations and two variables. We need to graph each one and then see if they have a common solution or if the two lines have a point in common. Alright, so these are in a form where they'll be pretty easy to graph, so let's use two different colors here to help distinguish. So let's graph this one here. Y is equal to 3x plus 5. We can see the y-intercept is 5. And the slope is 3, positive 3, so that's rise 3, run 1. Rise 3, run 1. And if we need to go backwards, we can do that as well. Okay, so let's connect those. And let's graph the other equation. Graph it in pink. See if we can tell the difference between. I think that'll show up fine. So we see the y-intercept is negative 5. And we see the slope is negative 1/3. So the line goes down left to right. Down 1 over 3. Down 1 over 3. It's just another point here, and we might want to go backwards a little ways also. So up 1, back 3. Up 1, back 3. And let's connect these. And carefully graphing these. The markers might not be as accurate as a pen, but hopefully we can see this point here. Alright, these two lines do share a common point, and we're going to say it's this point right here. And so we're going to name that point as the solution of the system because it's the only point that the two lines have in common. And that point has a value negative 3, negative 4, negative 3, negative 4. And remember, in order to check that, you should replace x and y values in both equations with these numbers and see that they check. Okay, so we'll do that in a few minutes. We'll test these points to see if they truly are a solution to the system. We'll save that. Let's go ahead and graph this system. Solve the system by graphing. So let's look at this first one. Y is equal to negative 2x plus 1, so we see the y-intercept is 1, positive 1. And the slope is negative 2. In fraction form would be negative 2 over 1. Down 2 over 1, down 2 over 1. Okay, and we can connect a few of those. Alright, now let's look at the other equation. Y is equal to negative 2x plus 5. So we know the y-intercept is positive 5. So we're going to find that positive 5. The slope is negative 2. In fraction form, negative 2 over 1, down 2 over 1. Now what do you notice? Down 2 over 1. It's the same slope as the other line, isn't it? So we already know from earlier work that lines that have the same slope are parallel. So we're not surprised to find that these lines are parallel. Now remember, when we're looking for a solution to the system, we're looking for a common point, right? Because these lines are parallel, there is no common point. So we say for the solution of the system, there is no solution. No solution, no common point. Okay? Well, let's take a look at this one. Solve the system by graphing. Y is equal to negative 2x plus 4, so let's take that one first. Y is equal to negative 2x plus 4. So we see the y-intercept is 4, and the slope is negative 2, so down 2 over 1, down 2 over 1. 2 over 1. So we'll carefully graph this. Alright, and now we want to take a look at the other equation. Now the other equation is not in the form where we can see the slope and the y-intercept. So we could use a table, or we could rewrite the equation for our convenience so that we can see the slope and the y-intercept. So if we take this one here and work on it, we could subtract 4x from both sides, start to isolate the y. That gives us 2y is equal to negative 4x plus 8, and then divide all terms by 2, gives us y is equal to negative 2x plus 4. Okay, now that's the same equation, but a different look, and for our convenience it allows us to see the slope and the y-intercept. So notice now that we've rewritten it, it looks exactly like the other equation, doesn't it? Which means it's going to graph this out as the same line. We have the same y-intercept and the same slope. It has all the same points. So we're going to show that one line graphs on top of the other. So for the solution of the system here, because the two equations share all the same points, we say there's infinitely many solutions.